Okay, students, this is our Unit 3 Part 1 video. This is factoring polynomials, perfect squares, and difference of squares. So first of all, I wanted to go over some vocab real quick, remind you of some words here. The first word is monomial. So this is a polynomial with one term, meaning something like 3x squared. A binomial has two terms, so we could see something like 2x minus 4. A trinomial is a polynomial with three terms, okay? So three terms, so maybe x squared minus 3 plus 1. Okay, so it's got three terms. Oh, let's make this 3x, sorry. Okay, so those are our different types of polynomials. Let's look at the word factor. So a factor is a number that divides into a given number without a remainder. I like to say that this is breaks the number down. So factors of 4 would be 1 and 4 and 2. So 2 times 2 gives us 4, and so it breaks the number down. A common factor is a factor shared by two or more numbers. So let me give the example of maybe 4 and 8. And so a common factor, there's several of these, but a common factor would be 2, because 2 can divide into both of them. If we wanted the greatest common factor, we would say it's 4, because 4 can divide into 4, and it can also divide into, oh, sorry, that was crazy. It also can divide into 8. Okay? All right, moving on to a perfect square. So in Unit 1, we talked about squares and square rooting. When you take the square root of a number and it equals a whole number, then we know it's a perfect square. So for example, if I took the square root of 49, so let's look at 49, and I take its square root, this comes out as 7, because 7 times 7 will equal 49. And so I know that 49 is a perfect square. Okay? All right, moving right along from our vocab here. All right, so the first thing we did was factoring out monomials, and here we have some steps. I do want to go ahead and go over these steps using this example that's over here. And our first step says to find the greatest common monomial factor. So I'm looking at this problem right here, and I'm saying, okay, what is the greatest thing that's in common in all three terms? And it has to be common in all three. If it's common in 2, sorry, it doesn't work. It has to be common in all three terms. So in this one, let's first look at the numbers. And this word greatest is kind of a little misleading. We are finding the greatest one that can go into all three of them. But students want to say, oh, well, then it has to be 49. Okay, but we have a problem with 49 because, yes, 49 can go into itself, but it cannot go into 7 and it cannot go into 14. So when you're looking at this, there's several ways to do it. I like to just look at it and say, okay, well, I'm going to find the smallest one first. I know 7 can divide into 7. Can 7 divide into 14? And can it divide into 49? And so, yes, that's actually what we're looking for. So 7 is the number that we're going to work with on this one. Now, I did have students say, Ms. Skyman, will it always be a prime number? And I thought that was a good question. No, it will not always be prime. It just depends on the situation. But I know that that is the biggest one because this number 7 right here, if I say 14, well, 14 can go into itself, but it can't go into 7. See how that's going to produce a fraction? And we want it to come out as a whole number. We want it to divide evenly, okay? So then when I look at my variables, I'm going to say, okay, let's look at the A's first. So here's my A's, and my A's. So it has to be common in all three. Well, this first one right here says I have 3 A's there. Okay. The second one says I have 2, and the last one, really, we can say there's 1. Okay, so when I think about this, I think, okay, well, if I have 3 in the first one, 2 in the second one, and 1 in the last one, well, it has to be common in all 3, so I can only take out or use one of the A's, okay? Because this last one right here only has one A. It doesn't have 3, it doesn't have 2, so I can't use that. Then if I look at the B's, so this one has one B, here we have two B's, and here we have three B's. So it's kind of like the A's, but a little bit backwards. So once again, I have to use this smallest one that only has one because it's only common with one there. I can take a 1 out of this one, okay? And I can take a 1 out of this one. I'm still going to have something left, but that's okay. But I can't take anything more than just a 1 out of this first one. And so that means that that would be our greatest common monomial factor. And that is what I was looking for this first step. Okay. Then step 2 says to rewrite each term of the polynomial as a product of the greatest common monomial. Ooh, that's kind of a lot of words. This right here says to undistribute. So basically what I'm going to do is I'm going to say, okay, I'm going to write 7ab, because that was my greatest common monomial factor, okay? And I'm going to say, okay, well, that has to times with what in this first term? What's left in that first term? Well, if I take 14 and divide it by 7, I'm left with 2. You guys see that? If I take a to the third power and divide out 1a, really what happens is an a cancels, and so I'm really left with a squared. And if I take out a b, there's no more b's left, so that's it. Okay? Then I'm going to write my plus sign, and I'm going to write 7ab again. So 7ab, because remember, I'm taking it out of every single term. And so then if I take out a 7, so 7 divided by 7, I'm left with 1. And if you want to write a 1 there, that's okay. If I take out an a from a squared, I'm left with still an a. And if I take out a b from b squared, I'm left with a b. So I'm really left with just ab. Okay? Then I still have a plus sign. 49 divided by 7, because I'm going to take out my 7ab. 49 divided by 7 is going to leave me with 7. Okay? And taking out an a is just leaving me with no a's. And taking out one b is leaving me with two b's left. Oh, goodness, that pen got crazy. Okay, so there's step 2. Now, step 3 wants me to go ahead and use the distributive property to factor out the greatest common monomial factor. So you can see that I have a 7ab common in all 3. That was our whole goal. So I'm going to take that and write it out in front. And this is where we use the distributive property. And I'm going to then put my parentheses. And what I have left in the first one is what we times it by, so 2a squared. And then I write it with what I have left in the second term, AB. I'm going to leave the 1 out for now. And what I have left in the last one would be 7b squared. And then I close my parentheses, and I have my answer. We just factored a monomial out. All right, moving on to factoring. Oh, this is another example. I think I'm going to skip it for now because I want to make sure we have enough time to get through all of the different situations we have here, and maybe we can come back to it later. So now let's talk about factoring out factoring perfect square trinomials. So this is key right here, perfect square. So you have to think that, okay, on all of these ones that I'm going to give you here, they're going to create perfect squares. Okay, that's the whole idea, because we're practicing factoring out perfect squares. Okay, so I have a situation here, an example, and I have some steps again. So I think steps kind of help us. It breaks it down and helps our brain to take this crazy looking thing up here and be able to factor it. So the first step says to write the polynomial in the form a squared plus 2ab plus b squared. Well, that's kind of confusing, I think, still. I think it's kind of hard to see what a squared and b squared are, okay? But you notice that over here, in our example up here on top, we have x squared plus 4x plus 4. So we have x's, and then we're talking about a's and b's, okay? Well, these a's and b's are just a form that we can always write whatever we're given out in, okay? The key thing is this, that we find what A is and we find what B is. Okay, so let me explain how to do that. A is always going to be wherever this first term is, okay? And B is always going to be dealing with the last term. And so when I'm finding A and B, over here it says to take the square root of the first term and the third term, okay? So that's what I'm going to do. If I'm looking for A, I'm going to go A equals. I'm going to take the square root. Woo, that was a crazy square root. The square root of x squared. And that will give me what A is. So now when you think about the square root of x squared, I like to tell my students it's like saying x times x. And when you take it out of a square root, you have to pair them up in couples. And so I take the two x's and pair them up, and then I get one couple. So one group of x's, and so it comes out as just an x. Okay? And then the same thing happens with B. I get B equals, and then I take the square root of this last term. Oh my goodness, these square roots are wanting to go out of control on me. So the square root of 4, well, that's saying one number times itself will give you 4. Well, the only one number I know is 2. 2 times 2. Oh my goodness. You guys are probably laughing because my pen is going crazy. Okay, so we're going to try that 2 again. And I don't know how to erase that. Okay, so B equals 2. And we just did our first step. So step 2 then says we're going to use one of these two patterns over here. Okay, so either A plus B and then squared, or A minus B and then squared. And to find which one we use, we're going to look at the sign in front of the second term. So that would be this sign up here that I'm highlighting in green. That is the sign in front of the second term. So if it's an addition sign, then that means I'm going to use the addition one. Okay, and step 3 then comes into play, and it says we're going to plug in A and B into the above pattern. So I'm using the plus one. I know that A is x, so I'm going to put an x in place of A, and B was 2, so I'm going to put a 2 in place of B. And that, my friends, is our answer. Okay? And you just factored that perfect square trinomial. So then if I look at one maybe with a subtract sign, let's do this again. This time, I see that I have a few different things. First of all, I see that I have variables here, and I have a number in front of this x. Okay, but that's okay. We're still going to find what A equals and what B equals. And we're still going to take the square root. And like I said, this is a perfect square trinomial, so it will produce a perfect square root. Okay? And so if I do that, I know that the square root of 4 is 2, and I know that the square root of x squared is x. We just did that on the last problem. And then I take the square root of 25y squared. So the square root of 25 is 5, because 5 times itself will give you 25. And the square root of y squared is kind of like x squared, right? Except for now we have y's. So we're going to pair up our y's into couples and bring them out, and that comes out as 5y. And so then I go ahead to my second step here, and I look, okay, oh, this is, let me change my color, this is a subtract sign, so this time I'm going to use my pattern that has a subtract sign in between, and I'm simply going to take my A and put it in place of where A goes into that pattern, just like we see over on the left-handed side. And I'm going to take my B and put it into here, so we get 2x minus 5y, and then the whole thing squared. All right, let's go ahead and then move on to something a little bit different. So first of all, I wanted to bring to your attention this slide right here. And it says, can you find the difference? So I want you to take a look at this and think, okay, what's different from the left-handed side of the screen to the right-handed side of the screen? Okay, so take a second, look at it, see what you can find. Some answers that my students said in class were, well, the left-handed side are trinomials. They have 3 terms, but the right-handed side only have 2, so they're binomials. Something else that we noticed was that all of this side has subtract signs in the middle, but on the left-handed side, they're mixed up, so they don't have to just be subtract signs. So what I want you to understand and take from this is that the left-handed side here, you notice that those are what we've been doing. Those are perfect square trinomials, okay? The right-handed side, these are actually called difference of squares. And so that's what we're going to do next, okay? So when I look at factoring difference of squares, this is where I have something like this, okay? And you notice that our steps start out the exact same way. So here, oh my goodness, these arrows are going crazy on me. So you notice here that our step is the same. Find A and find B by taking the square root. So I'm going to take the square root of the first term, and we don't have a middle term, so I take the square root of the last term. The first term will always produce A squared, or I mean our A, and the last term will also always be our B. Okay, so when I find the square root of 16m to the fourth, okay, so when I think about that, the square root of 16, well, what number times itself will give us 16? That would be 4. When I find the square root of m to the fourth, okay, this one's kind of tricky. You have to think back to what we did for square roots. But really, this is like saying I have m times m, and these m's are kind of tricky with my pen here, times m. Ah, see, I told you they were tricky. Oh my goodness. Okay. Wow, and it's not even wanting me to write another m. Let's write it on this side. Okay, so then I group them into groups of 2 because remember we're taking the square root. So we're grouping into couples. That comes out as 1, and that comes out as another one. So we really have m squared. I hope you understood that. Okay, then when I take the square root of 1, well, what number times itself will give us 1? Hello, it's just 1, right? So now moving on to step 2 here, it says that we need to then plug A and B into the difference of square pattern. So now remember on the last slide how we had like A plus B and then squared? Well, this time this is the only pattern we have. And so I'm going to write that over here. And I'm going to put a plus sign in this first one. And then I'm going to put a subtract sign in the second one. And it will always equal this, okay? You just have to find out what your A is. So then I just plug A and B in. Okay, so A goes first, and so we do 4m squared, and then B, which is plus 1, and then we do 4m squared. Ah, those m's are out of control. And it would be minus 1 this time. And we just found our answer. That's it. So that's factoring difference of squares. And I think I had one more question I wanted to do real quick with you, so I'm going to do this quickly. I want this to not take too much longer. And then you can just watch, and maybe hopefully you can catch on. So once again, we're finding what A equals by square rooting the first term. The square root of 144 is 12. X squared comes out as x. And then we're finding what B equals. And so we take the square root of z squared. And we get z. That's it. Okay, not 2, but z. I'll put a line through it like that so you can tell. Then I take those a's and b's and I plug them into that pattern down there. Oh my goodness. And the first one is plus, and the second one is minus. And so we do 12x, and this is z. And then we do 12x again. See how I just rewrite it again, but the first one has a plus sign and the second one has a subtract sign. And this one is z. And there's our answer. All right, I hope this helped you with the first half of Unit 1. Stay tuned for the second half.